The region R is bounded by the graphs of f of x equals square root of x and g of x equal x squared between x equals 0 and x equal 1. What is the volume of the solid that results when R is revolved around the x-axis? Okay, the first thing we're going to want to do is sketch our region R so we can visualize what our volume of revolution would look like. So we have, first of all, our curve f of x equals square root of x, so that graph would look like this. And then our second curve, g of x equal x squared, that's just a basic parabola, so looking like that. So we can see our region R, and they intersect right here, and this is the value when x equal 1. Square root of 1 is 1, and 1 squared is also 1. So let's see if we can visualize what this would look like, and we're going to be interested in taking a representative slice here and imagine what that would look like as we rotate this around the x-axis. Here we have our region, and let's go ahead and look at our little representative. We've got a little rectangle, we've got a little thickness dx, and we're looking at this slice, and as we revolve around the x-axis, we see that this slice ends up forming not a disc, but a disc with a hole in it, which we call a washer. If we were interested in finding this area, we could take the area of the big circle and subtract off the area of the little circle, and we would have the area of the washer, and then if we multiplied it by the little thickness, we would have the volume of that slice. Let's go ahead and see what the solid would look like if we rotated that whole region around. And we get, as our solid of revolution, it looks bowl-shaped, but the interior is curved because of that other inside curve. And that's what it would look like. Now let's go back and see if we can express then an integral that will lead us to the volume of this solid. So what we're going to do is we're going to be integrating from, our x values are going to range from 0 to 1. And if we look at this, if we found the disk and then we subtracted off this hole in the middle, this little disc that formed the hole, we would have the washer. So let's go ahead and express, first of all, if we had rotated this and the curve had come down here to the x-axis. So that's going to be pi r squared, and the r is going to be our y value of this upper curve, and that upper curve was square root of x. So square root of x squared, that's just the area of a circle, pi r squared. And then we are going to subtract from that this piece here, because that would be the whole. So that would be pi, we're going to call that little radius squared, and that would be the y value, or the function value, of this lower curve, that lower curve being x squared. And then we need to square it so that we have pi, basically we have pi big radius squared minus pi little radius squared. And again, rather than memorize a formula, we want to look at the picture, and then we need to multiply that by our little thickness dx. So if we can evaluate this integral, we will have the volume of that solid that was generated when we rotate that around. So our volume going to be, we've got a pi that we can factor out, and then we're going to go 0 to 1, square root of x squared, so we've got x minus x to the 4th dx. This one will be easy to integrate then. This would have been 1 higher power multiplied by the reciprocal of the power, and we'll do that in this case as well. So multiplied by 1/5, and this needs to be evaluated between 0 and 1. So it looks like we have here pi multiplied by 1/2 minus 1/5, and when we subtract off the lower limit, since the lower limit we're substituting in 0 and have x's in both of those, that's just going to be 0. So it looks like this would be 5/10 minus 2/10, so it looks like we get 3 pi tenths for our volume.